Section 6-2 is going to be focusing on parallelograms. Previously, we have classified polygons with four sides as quadrilaterals. Now, we're going to recognize and apply properties of the sides and angles of parallelograms. We're also going to recognize and apply properties of the diagonals of parallelograms. So what is a parallelogram? A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Parallelograms are named by their vertices, and we use a small parallelogram symbol to indicate that a quadrilateral is a parallelogram. So this parallelogram would be parallelogram GRAM. The pink arrows on the diagram indicate that segment GR is parallel to segment MA, and segment GM is parallel to segment RA. When given that a quadrilateral is a parallelogram, you can conclude that both pairs of opposite sides are parallel by the definition of a parallelogram. Now we're going to go over a few theorems related to parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So on the right here, if JKLM is a parallelogram, then segment JK is congruent to segment ML, and segment JM is congruent to segment KL. Now we're going to prove the theorem. Given that WXYZ is a parallelogram, we want to prove that segment XY is congruent to segment ZW, and that segment WX is congruent to segment YZ. Notice how we draw a diagonal from Y to W, and we make two triangles. If we can show that these two triangles are congruent, then the opposite sides of the parallelogram would be congruent by CP/CTC. For statement 1, we use only the information we're given, which is WXYZ is a parallelogram. Since WXYZ is a parallelogram, we know that the opposite sides are parallel to one another, or that segment WX is parallel to segment YZ, and that segment XY is parallel to segment ZW. We know this is true by the definition of a parallelogram. Now that we have two pairs of parallel lines and transversal YW, we can conclude that angle XYW is congruent to angle ZWY. Why is this? Marking the congruent sides on the diagram helps us to see that we have a congruent angle, then a shared side, then another congruent angle in each triangle. We know that the shared side, segment WY, is congruent to itself by the reflexive property. Then triangle WXY is congruent to triangle YZW by which triangle congruence theorem? Triangle WXY is congruent to triangle YZW by angle side angle in statements 3, 4, 3. But we're not done yet. We wanted to prove that segments are congruent. So our final statement has to be our proof statement. Segment XY is congruent to segment ZW, and segment WX is congruent to YZ by CP/CTC. Our next theorem states that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So if JKLM is a parallelogram, then angle J is congruent to angle L, and angle K is congruent to angle M. Here is the proof that opposite angles of a parallelogram are congruent. Please review it, and if you have any questions, feel free to come ask in class. Our next theorem says that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if JKLM is a parallelogram, then x plus y should equal 180 degrees. Since JKLM is a quadrilateral, the sum of the interior angles is 360 degrees. Therefore, the measure of angle J plus the measure of angle K plus the measure of angle L plus the measure of angle M equals 360 degrees. Substituting gives us x plus y equals 360 degrees. Combining like terms gives us 2x plus 2y equals 360 degrees. Factoring out the 2 gives us 2 times the quantity x plus y equals 360 degrees. Dividing both sides by 2 gives us x plus y equals 180 degrees. So if the sum of the measure of two angles is 180 degrees, then the angles are supplementary. Our final theorem for today says if a parallelogram has one right angle, then it has four right angles. We can demonstrate this theorem algebraically. So let angle J be a right angle as shown in the diagram. The measure of angle J is then 90 degrees. Since opposite angles of a parallelogram are congruent, angle L must be congruent to angle J. Therefore, the measure of angle L must also be 90 degrees. Since consecutive angles of a parallelogram are supplementary, the measure of angle J plus the measure of angle M must be 180 degrees, giving us a measure of angle M as 90 degrees. Angle K is congruent to angle M because opposite angles of a parallelogram are congruent, so angle K is also a right angle. And since K is a right angle, parallelogram JKLM has four right angles. For example 1, we're going to be using some of the properties of parallelograms. What we need to do is find the values of x and y in parallelogram QUAD. Which property of parallelograms can we use for this? We can use the property that opposite sides of a parallelogram are congruent. So by this, we know that segment QD is congruent to segment UA. Because the segments are congruent, it means that the measures are equal. Since we substitute the measures in, we get 4x equals 8, or x equals 2. Similarly, we know that segment QU is congruent to segment DA, meaning the measure of QU is equal to DA. Substituting gives us 3y plus 4 equals 13. Subtracting 4 from both sides gives us 3y equals 9. Dividing both sides by 3 gives us y equals 3. For our next example, we're given that KMOQ is a parallelogram, and we need to find the measure of angle K and the measure of angle M. What types of angles are angle Q and angle M? Angle Q and angle M are opposite angles. Since they're opposite angles, they must be congruent, which means that their measures are equal. Therefore, the measure of angle M must be 35 degrees. What type of angles are angle Q and angle K? Angle Q and angle K are consecutive angles, and since they are consecutive angles, they are supplementary, and the sum of their measures must be 180 degrees. So the measure of angle K plus the measure of angle Q must equal 180 degrees. Substituting in 35 degrees for angle Q gives us measure of angle K plus 35 equals 180. Subtracting 35 gives us the measure of angle K is 145 degrees. For our next example, we're given that WXYZ is a parallelogram, and we need to find the measure of angle W and the measure of angle X. Since angle X and angle Z are opposite angles, we know that they are congruent. Since they are congruent, we know that the measures are equal, and therefore the measure of angle x equals 125 degrees. Likewise, angle z and angle w are consecutive angles, and consecutive angles of a parallelogram are supplementary. Therefore, the measure of angle w plus the measure of angle z equals 180 degrees. Substituting in 125 degrees for the measure of angle z gives us the measure of angle w plus 125 degrees equals 180 degrees. And therefore, the measure of angle w is 55 degrees. For our final problem, we have a real-world example. In parallelogram ABCD, suppose the measure of angle B is 32 degrees. The measure of segment CD is 80 inches. And the measure of segment BC is 15 inches. For our first question, we want to find the measure of segment AD. Since segment AD is opposite of segment BC, we know they have congruent measures. Therefore, the measure of segment AD is 15 inches. The measure of angle C is supplementary to the measure of angle B. Therefore, their sum is 180 degrees, and the measure of angle C is 148 degrees. And since angle D and angle B are opposite angles, they must be congruent. Therefore, the measure of angle D must also be 32 degrees.